Hello and welcome back to yet another session of our opencv course. In this session we will deal with image transformation called resize. As the name suggests, resize is actually changing the size of the image. But while changing the size of the image, the thing is that the image, there is a greater chance that the image will stretch or it will shrink. So in that case, we need to take care of the aspect ratio of the image, so that the image will appear in the same form when the size is changed. So aspect ratio can be called as a proportional relationship of the image width and height. For example, if it's a large image or a small image, the image will appear same. So in order to implement using opencv, we need to calculate the ratio first. So here we are doing a calculation like this. We are going to divide the new width we are defining it as 150 divided by the old width of the image. Here it's 150 divided by image.shape of 1, which will return the width of the previous image. And we now have the R value, and we are trying to get the new dimensions of the image by using this R value. So the new dimensions will be, we are keeping width as constant. So the width will be constant. So if it's a 500 pixel image, we are resizing or we are shrinking it to 150 pixel width image. And if it's a 50 pixel width image, we are enlarging it to 150 pixel width image. So width will be constant, but the height is what we are going to be keeping as dynamic, so that the aspect ratio of the image will be maintained. So in order to find the dynamic height, we are using the ratio R, which is 150, the new width divided by the old width, and we are going to multiply that value with the height of the image. So this is a formula that we are going to use. So to find the ratio, we are going to divide the new width by the old width, and to find the dimensions of the new image, we are keeping width as constant. Then height can be found out by multiplying the current height of the image with the found out ratio value. So that will return the dimensions, the width, and this part will give us the height. And now we are using a function called resize, which is a part of the opencv. We are using cv2.resize. The first argument is the image, the second argument is the dimension that we have, and the third argument is the interpolation method, which is actually an algorithm that is used by opencv to perform the resize of the image. We have few choices. We have inter area, inter linear, inter cubic, and inter nearest. These are the algorithms that opencv is using, and inter area is the best among them in accuracy and in while performing the resize. So we are using inter area, but these are also used based on their respective use cases. And now we are showing the image exactly the same like what we had in the previous exercise. And in the previous exercise, we created a common file in which we can define the functionality called IMU Tools. Here also we are going to include the resize mechanism inside our IMU Tools file, so that we can use it very easily in our main program. So here we are defining the function. The function will take arguments image, then width, then height, then the interpolation method. So the image will be passed. Width, we are initializing it as none. Height, we are initializing it as none, and the interpolation is initialized as cv2.interarea. Now, after indenting, we are initializing the dimension is none. Then we are getting the height and width of the passed image, the image that is passed into the function, and it will be saved here. And we are checking if the width passed into the function and height passed into the function is none, then no need to resize, because user didn't pass any new width or new height. So we can return the exact same image that we got into the function. And if the user specify a width, we need to calculate the R value. And if the user specify the height, that is the width is none, the user specify width as none, he should specify some value which is the height, right? So while resizing, we accept only one value, even if it's width or height. So in this resize function, we consider only one value at a time. For example, if the user is applying width, then we take width. If the user is applying height, then we take height. So if width is none, that is there is some value with height. If the height is not none, then r equal to exact same formula, the new height divided by the old height. Then we are calculating the dimensions as the same formula. Here it was width, so we multiplied the value we got with the height of the image. And in this line we are checking if the width is none. Width is none means there is some value for height. So we are assuming that there is a positive value for height, and we are calculating the r value based on height. That is new height, which is defined by the user, which is passed here, divided by the old height that we got here. So new height by old height, which is a value that is saved in r. And now we are going to find out the dimensions. The dimensions is when the dimensions, exactly like the previous screen we had, the dimension here we kept width as constant, but here in this case we keep height as constant, and we find out the dynamic width, that is width into the r value, that is the old width of the image into the r value. The same thing happens here also. Here in this case the height is none, that is there is some positive width. In that case we are calculating the r value based on width. Width is a new width divided by old width. It will get a value in r, and the dimensions we are keeping width as constant, and we are calculating the dynamic height, that is old height into the r value. Now we have the dimension ready. Let's go ahead and resize the image by calling the function cv2.resize. The first argument is image, the second argument is dimension, either it is returned from here or here. Then the interpolation. Interpolation is actually the inter area. If you want to specify, you can specify, or else it will take cv2.inter area and it will return the resized image.